Okay, I'm picking up right where I left off. The dropping off for the work messages and stuff is done. It was pretty quick. Able to take care of that work after this. This is just such a focused priority right now. What I'm doing, having recently completed a ability to extract links from a one-click depth crawl of a site, I'm coming back and getting a lot of relative links in there, which I uh, believe I had tried to avoid here. But when I say for a link in the raw links that were discovered as a result of this soup query, I'm getting find all A where href values exist. However, I filter out when href values are these things. So everything else that matches that criteria comes through here as a link. And then I say href equals URL join the site to a link. Href, this is where I get those rel equals, I'll join cell lower end link. So I should have some if logic around here. Those hrefs that are being set, value we're really sitting on is a link, and a link has href value. So we really want that href value to be distinctly separate if it's on-site or off-site link, so that we can do this or not. But I would think that this statement would have made everything look like it was on the site. Href, let's make sure it's getting a it's append. Yep, yeah, relative and the href, that href value that used in that append right there. So there's an on-site, off-site kind of thing here that, you know what, I'm going to turn this into a lesson, breaking it out of a function for debug. And I guess I could do it right in location. Edit out that first one, just this entire thing. Actually, we edit out the return value as well. Now we've got a block of code that can be run directly. If you set site value, this. Actually be able to see this do its thing as it does the loop. I'm just going to do an experimental run here. The return is outside. I have a couple of return spots. That's generally bad practice. See why. Oh, return links. I guess it just is detecting that even down. Nope, another return links. There it is. That one. But I'd like to keep it now. This had in mind about return value. Detected error under try. Yeah, because if I edit that out, that needs to be a passive. So you see how fast that really finishes? So I can actually print links as a last step and should be able to see the thing going wrong, which now gives us a rapid way to that correct when I look at it this way. So correct. Still doesn't explain why if logic that I think should be there to separate the internal versus external for that URL join. Working. URL join can't be that bad. Sites that look like. So lots of stuff can be done here. First of all, we can get rid of this printing of links, and we can each thing as counter it. I think that the links found here are already correct, already made absolute because it's that. Let me try jumping in like this. Get rid of that sort of home page perfection that's often built into sites. Still look all like fully resolved, or at least fully qualified URLs. My site. It looks like it has that. Let me see what happens when I edit out the pointing. Yeah. Right here. It's just showing the Ahrefs that are found. Should be some fully qualified ones. Let's get 2 of them. Work with that. A couple of /US sites. Those should become residing on the site. If before we do an if, we're just going to do something else. We're going to print ahref 7 in. Doesn't have HTTP. It's 5 when it's not for HTTP, so it's really 4 that I want. Not HTTP. It's a relative link. So the logic goes, if that equals HTTP, then no further work is required. If I hate doing this stuff, but I'm gonna do it anyway. Href That is not right. We want href for printing. Okay, so ahref, this is one of the alternatives. ahref should absolutely be equal to the x of ahref because we need to be able to evaluate against it. Until we do this, ahref equals x of ahref. Now these evaluations will work if that equal to just HTTP. Oh, but now we have it. We're sitting on top of it. We've already done this. So that elif condition that I was thinking about becomes our if condition. This equals, see, it's almost always equal to HTTP. You don't have to check it when it's equal to a slash or anything other than a slash. Well, okay, other than a slash, we got to trust it. Okay, so we do check this. You know what? We just keep it like this for now. Don't need the extra things. So the check is going to be really against this. Then href equals that value because you don't have to do anything. href equal to that value exactly. Because it's an absolute link. Pass on. Elif, else, we've already filtered out a lot of bad stuff. It's really a good time now to just make a direct grab for joining the site to this a-link ahref or a-link in x for x. I almost made a mistake. This is a-link. This is a-link. Else, join it. That's looking pretty darn good. Got to print stuff, of course, for you to see that it's working. And I guess I should print it elsewhere so it's a little bit more pure. Sure, we can see that place where there was the relative path before in /us. See that it became expanded into a location on this site. I don't see the super indented stuff, and there they are. They got turned into absolute links. I'm pretty sure this step here did it. And now we're going to turn it back into a function. This out. Putting that back in. We'll leave indenting everything, including this. Turning links there. So we do have to check. Yep, we always return links no matter what. Even if no R, you're empty set from some other condition. Now we put that in memory. This is applying it against the time instead of my site. But look at how quick it did that. Oh yeah, that's printing what it encounters internal to the function. That's really interesting. I can get rid of that print statement a little bit over the top, considering how many links are going to be encountered in here. Still working. I'm going to exit out of that because showing 40,000 links is not what I want to do. However, this is what I want to do. Populating that responses object again. You can see this has already executed. So we have now entered into that, 90-second waiting for one depth crawl of the site. Get back all the response objects, which then will be unified into a list of final links, which I'm doing outside the crawl function, although I may put it internal to the crawl function. But by doing it outside the crawl function, I can do some rapid experimentation while having turned that back into a function like it should be. Now, this turning things into and out of a function, this is really something that's going on now a lot because of the data science world jumping on top of the Python bandwagon and using Jupyter Notebook to do it, because Python without Jupyter Notebook actually kind of difficult. So for the average mortal, it's very much worth using a Jupyter Notebook. However, this REPL environment makes things easiest to debug and to get the advantages when they're not inside functions. But at any rate, there's that list of final links. We'll take a look at it, and everything that began with a slash should just be gone. Everything should be an absolute site link, either on site or off site, fully qualified HTTP:// Final links is not the. Oh yeah, I just did this. I did not. Well, no, I thought I did it. Oh yeah, it went through there, 91 seconds. I can do final links extraction. They're REPL type. Because you're executing block by block. Blocks. Okay, well, I mean, printing it as these member of the set, so I'm going to make it look a little nicer. I already see there's some that are leaving the slashes. Darn. Nothing should ever be able to lead with a slash or anything. In fact, anything other. So these are discovered links. Always goes through. If R, soup equals extraction of all the A to the href values. We get the parts of the site that went in originally. The union actually netlock, although it would also require the protocol. The URL join, I was hoping to do. No, URL join does exactly what I expect it to do. But not applying itself to every link found. So for every link found, it satisfies these conditions, either an on-site or an off-site link, not the actual. has to be this else condition. So if excuse me. These are innocent sneezes. So when you go in this function, for every link found as a result of one of these soup things, if the leftmost characters begin with HTTP, the leftmost 4 characters, then the href value is set to the entire thing because it's an absolute link. Else, URL join cite that same link ahref append that ahref value we just created along with rel. Everything being fed through this links should in fact be able to always return absolute links in any circumstances where relative slip through this, but yet they clearly are. Emergency alert just went out over X system. Help people learn what to do. Our situation. Not coming to me for that sort of stuff, so I'm not going to talk about it. Still 2 people watching me. This is completely amazing. Oh, someone's asking me how potential. Oh, and it didn't go out into my live chat there. Sorry to have left you waiting. People who have that question for me. Yeah. Who am I to say? Okay, so the best thing I have to say, it's not really the best answer in the world, but how will the potential economic recession affect tech jobs? Everything's going to be affected. I don't want to answer by saying too little. So the most everything else is so loaded in that answer. I would say learn tech. I don't know. To this situation, it's more advice than how it will affect. So it will affect. Advice is to learn those skills that will be most demand during these times, most able to be delivered from remote locations. Tech in general is still in demand, and happily, thanks to the cloud, able to be delivered from remote locations. been spending years preparing for this by making in-person hardware access servers unnecessary. A huge gift. The fact that most of our work can be done remotely these days. How many other industries can say that? Food service can't say that. Amazon delivery people can't say that. And okay, people still with me. All right, so this has become debugging. There's no way that these relative links should be slipping in, but yet they are. So there's something wrong here. So we're getting response object every page. We're still sitting on that. And for a response, responses, some links equals links this. That's feeding the whole HTML into the links function, which should return back with something where all relative links should have been absolutely wiped out, but they're not, right as early as this. So once again, look and stare. What am I doing wrong? So R gets set equal to none, links get set equal to empty. Site does some cleanup. If not site, and the cleanup includes R equals populating the R object. Else, if this guy exists, R equals that. R. Soup equals beautiful soup, blah, blah, blah. And then we execute the query soup find all, where AH is true. And then I just take the parts of the site parameter that came. Is there a site parameter that always still comes in? Oh, site equals none. We are not feeding the site parameter. We are only feeding the response object. So because there is no site parameter, well, that can easily be solved by making the site parameter required. Okay, we execute that function. Yeah, we have to go through this again, but it's not going to work. It's going to fail out because one-click crawl. Now, one-click crawl won't fail, but one-click crawl is going to call the link function internally without the site parameter. So I should just be able to look down and spot that because I wrote this. So the links does not use links inside of it. Crawl function, one-click crawl function certainly does. The one-click crawl function is still up here. Here's one-click crawl, and it's the links function here. Oh, site is being used on each one of these. Site is not being used later, being used on the initial one. Call the request object. back responses, all those response objects back for a response. In response, this is where I apply the links function without using a cite function. This would fail. So this would work. We put all that link stuff back in memory. This works. The one-click crawl. In fact, that data is probably all still the same because I fed that in. Really, all that's different is this. Cite equals cite. Now, this should be correct. Such a small touch, right? How long did I go and how much did I talk out loud? But you can see all the issues that are in play, like required parameters, positional parameters. Positional parameters are required parameters. And when you set a default value, they are no longer required parameters, but they have to come after your positional required parameters. So blah, 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 absolute links should be gone. I don't know why it's taking so long. Walk through objects that are already in memory, fetch locally, except for the fact that they are so huge. Regular expression match, link extraction. I don't know exactly why it's taking. But this is not getting anything off of the web anymore. This is all local, just processing stuff in memory locally. Or is it? Links. Oh, the links does, in fact. Oh no, but it doesn't. Cite. So cite equals, that's why it's taking so long. There is ambiguity here. Darn. Darn. The best laid plan. It's going to take a long time. Escape 0, but at least now I have a grasp on the issues. So it's still going to attempt to do the fetching of the cite because the if logic of cite being set is happening. So a response, feed links to a response, cite value, which is going to have to be later, get extracted out of the first response. First response list is the one that is the correct site URL. I don't know. It's fine. So something like this. Get that back in memory. We get these guys back in memory. We go back to making site optional. Know that if it goes through this route, site has not been set yet, but we're sitting on top of a requests response object that site totally be set to our resp.url. Now we have a site value later on in there when it's necessary for building absolute. We do our one site crawl, which is going to take that minute and a half. There's just no way around it. I mean, I could cache it, but the way around it is the caching. That is probably much more polite to do to these sites, and I'll probably bring back the cashier very soon, as soon as I'm happy with the behavior of the crawler. But we do have the 90 seconds to wait, so we shall. So this isn't longer than, yeah, 72 seconds, right? Not bad, not bad. Now we should be able to do this, which steps through all those response objects, gathers together all the links, and look at the links. Yeah, 2,957, even fewer than before. That's because they are all now absolute links, and the deduping is more effective against a somewhat normalized list. And so here's all the href values that have been collected from a one-click depth crawl of a site. And you can see how truly, effective such a quick little process can be. Now, the landing page URLs have not really been expanded except on site, and that's the next step I was talking about before getting distracted by the fact that they were not all absolute links yet. So to give you a little more idea about this whole absolute link business, URL parse, and URL join, and all this stuff that's URL aware that I'm using, site this above here so you can see what I'm talking about. We have site in memory still. Now this URL parse function that goes around URLs breaks it into its separate pieces, named tuple. Anyone who has used URL parse is using the tuple and recognize it by the presence of an object name and by named argument parameters. And whenever you have a tuple, a named tuple, put dot and then an extension and lock, for example, and you can see you get just the domain. Now you have something really good for evaluation purposes. You can actually abbreviate that by saying DOM or whatever equals that. So now compare if that link is going to have the same thing, we use the same thing link. But because it's the same every time for DOM, you don't want to put it through that function and have that little extra bit of overhead. So you can say if the one there is that, it's going to be on site. So this is just your on site link. And you can reverse that all very easily too. Not equal. Offsite links. Here's your offsite link. You can also do that as list comprehension if you wanted treat that as one line. Good to see this comprehension is final links. As I've always instructed, for X in, and there's if statements. There's a question of left or right. Right goes filter, left goes leaving nuns or whatever, integrity intact for stuff, for dumb join. Smart. You'll always join on a column. Hope I'm speaking up enough. Hope this makes sense. But at any rate, this is becoming a list comprehension. Now, filter. We'll go right over. That's the same thing. That's all your offsite links. But now you can do things like length of that right around it. You don't have to it. And one thing that's nice, you can do link expansion on that. This would now get to the wisdom of keeping visits separate functions. I even did that. I don't think I even did that. It's as the new crawler I made. Oh, resolve landing pages. I do have that. So this would be resolve landing pages against that. And the time is already in there. This would be really interesting. Shall we do it? Landing pages. It returns a landing page dictionary, which is fine. Twice the amount of information. You put it through one filter to just get themselves. This is resolved offsite. offsite links equals resolve landing pages for this value here. Now we can just, instead of saying the length, set that to something so we don't have to go over the place. Offsite links. Now this is going to take a while. This is, if you remember now, length of offsite links. Now because it's offsite links, I think I'm going to unthrottle it a little bit. I've had these concepts of throttles, and because it might be hammering against the exact same site. I have things like this 20 in here because if it's against the same site, you don't want the same site. But since these are off-site links, I'm going to pump that up to like 100. Get as best throughput as I can for this step, which is resolving 1,316 off-site links. Let's see if I can think of anything to talk about with you while we do that. Now, there's the on-site links as well, but it's a whole separate issue. Expanding on-site links only will find you broken internal links, internal URL shorteners or redirectors. And there's probably better ways to do that, especially since it's still the largest part of the list. Well, splits a little bit evenly, but it looks like 2,957 of the 2,957 links, 1,316 of them are offsite, which are the type that I really particularly care about resolving the URL of the landing pages. The issues are larger than just links. So I'm going to definitely apply this function against the offsite link. This dictionary back. I'll look at that dictionary in various ways. Again, we'll do that comparison as to real link, the reported link crawl versus resolved link, actual visit. And what more can I talk about? Well, check is with me. Wow, 2 people still with me. No one's who's actually talking to me anymore. Any questions? Live stream catching up with me. Feels like there's a little bit of a delay. I didn't ask for any delay. What the being? What the? There's enough in here for me to save and commit. An interesting thing, even while it's going through its little process there, do a save your lab. Save there. Then get status just for interesting sake. Oh, stuff is being put in crawl data. Oh, crawl has been created. All the way that old crawl function. The old crawl function. Crawl. There's nothing in there. If there was anything in there, it would be reported here. So it's just modifications here. Git commits. Fixed did I fix? Absolute links. Link function receives response object. Requests response object. Largest comments ever made. That's still going on a bit. This is to be expected. It's unfortunate. This is one of those steps in what I'm doing, in the process I'm doing. It's just very hard to get away from. And I'll have a timing measure of how long it took to fetch true landing pages. This is the same as performing a crawl on those. I'm visiting those 1,316 pages just in order to get their correct landing page. Go through any redirects, redirect chains, or any URL shorteners that might be used, because that final landing page is actually quite important. Doing certain types of SEO analyses. I'll be turning this into a external library. Everything that's in a function or is kind of behind the scenes setup for those functions is going to be moved to mlseo.py, and there will be no mlseo.ipy or IPython notebook. It's not really worth continuing to develop library type things as IPython notebooks after a certain amount of time. You want to just keep .py files and argument for yes code to get you book-like capabilities in that circumstance. But by the time it reaches an external library like that, the idea is that these are just your building blocks for applications, so that your actual code for your application becomes much easier. In fact, this little piece here, thinking of putting internal to a function so that crawl function. Amazing, it's just one piece of code like that. I'm looking for this big thing, but it's just this crawl function here, which returns a set of responses, may actually just return a set of the final links, having gone through some of the other stuff, maybe separating internal and external links, so that very little is necessary in the scripts that you build out of the new capabilities you've got sitting in modules. Waiting for a crawl like that, even when comparing. Just nobody wants to do it. Nobody wants to do it on a live stream, but we're going to wait for it to get done. There is no pause on life. That important to my job now. I see this kind of crazy, time wasting meandering. All these YouTube videos that are out there for people playing games. It seems stupid to me that all this stuff is dedicated to these games, when if you dedicate it to thinking in Python and process automation and just becoming literate. This is really what's on my mind. This stuff. Learning Python is increasingly becoming being literate. I'm sorry. Some people might say it's that way with JavaScript. It's not that way with JavaScript. JavaScript is a nice language to know. For right now, for your career, for a snapshot in time. But Python is a good way to be. Clear thought, little obscured. And for those who, can't stand, the loosey-goosey nature of Python, the thing for you to research is called it's not myint, mypi. That's built into Python now. Python something is included in it by default. And if you activate the mypi option while you're working, all that loosey-goosiness of variable scope slipping because they didn't define it anywhere and first usage is ambiguous, you can essentially switch Python into a much more Java-like static variable definition environment, static typing. I can tell the script is still going by that hourglass. We're waiting for the hourglass to go away. And this is becoming a long stream merely because I'm waiting for the output of this function, landing page extraction, so I can have a figure that this many pages on a fast site and all the sites that this fast site links to resolve 1,316 pages took X amount will be output because of the way I show the number of seconds that this takes. Now, this resolving of the landing pages is totally using this concurrent behavior that I discovered how to speed it up and to have a simple API that's used here in landing page expansion, and it's also used here in the one-click depth call function. Different call function, similar but different things, using the same technique, time measurement. But whereas this is interested in just the landing pages as a landing page dictionary that gets extracted, this is returning everything having to do with retrieved, crawled pages, so that we can extract information from off of the crawled processing. Though, as you can see, very difficult to see what's going on in the background when you use that technique. I know that Dask is the way to have that input into what's happening over threads when stuff is broken into threads. So I want to take a look at Dask G requests, see if there's any relationship between those two. One's talking about it. Plenty of Kubernetes cluster. Oh, you know what? I'll answer that guy's question. Learn Kubernetes. That's kind of like the Pat learn JavaScript response. Job security right now, learn Kubernetes, because Docker and all the things having to do with packaging up your apps so you don't really have to do much but plug them into plug-in infrastructures. This is the plug-in infrastructure that's so popular. Because I'm not a big infrastructure guy, the Dask is more interesting to me than Kubernetes. But if you're looking for, what to do, go into a global economic recession, it couldn't hurt to learn Kubernetes. This person is saying, why is that mapping so slow? automation. Selenium, I could answer that question for the person. If you find the example of G request so slow, it's because this get command has other optional parameters that can be put in there in order to turn off the streaming feature websites are hitting, which locks up your connection pool because it's open streaming. You get a very, very large throughput increase by putting, as if we were enjoying it, this should be, but by putting stream equals false. Hey kitties, get along with each other. Still not done. I'm going to wait it out. Landing page expansion hardly seems worth it. I don't know what you're going to get in terms of pages you discover, different pages, URL you crawl against every site you crawl, their off-site links different, and all this stuff that I do in order to sort of speed it up in case it's pending data type like a .gz, a .pdf. I should, you can't look to say, is it .html? You can look for the content type. I do this, and then that adds an extra bit of fetching. It's actually 2 fetches per thing, but it's really worth doing it because you want to keep yourself from retrieving anything, parsing that isn't text. I might try and look for the size of the file being fetched and not fetch anything over a certain file size. That might be a good idea to speed up this step. But for right now, an awful long video just to show you, oh, here's a list of URLs that are the expanded stuff of what was discovered from this crawl. It seems like the project is mostly finished now, and I shouldn't waste your time and just keep this URL expansion as a in our back pocket for when it's server and you don't have to sit there and wait for stuff going. Oh, that's also one of the things I'll be doing soon. I'll be showing you how to move stuff to a server. So, Python place locally, experimentally, with REPL environments like Jupyter Notebook. But it's also nice when you have to lift that code up and put it on a server for scheduling. Python code can be run from the Linux and other command lines, meaning it can be parameterized. So your same script runs different ways depending on how it's called on the command line, making what you wrote a function, even if you weren't thinking of it that way. Because you didn't use any def keywords to define functions. Entire notebook turned into a .py file and made to support input parameters, values, fed values, becomes a function. And it's still not done. I don't think I'm gonna make you wait, but I will talk about the process of making a function that I'm talking about. Well, I have to put in the thing to support the arguments at the top. And, I feel like I'm just running out of steam. I think this is a good place to wrap up. It's coming up on 7 o'clock, well after the work day, and I've been at this for a while. Most of my main goals have in fact been achieved. So I will wrap up, pick up tomorrow. Though I may not be streaming, so definitely chime in, leave your comments, and tell me what direction you might like to be going with this. Thanks for joining me. Don't forget to subscribe.